So now we'll look at some of the environmental impact of some of these new technologies that we hope to adopt. So um, now, when you process material and manufacture them, so for instance, when you for solar cells, all the semiconductor um, that you need to process and make, those are some resource intensive technologies. Okay, and also uh, during the operation of these facilities, what is the environmental impact? And you saw that for most of the renewable energies, the operational impact is very minimal. Okay, uh, so any contribution that renewable energy sources have to greenhouse gases are just during manufacturing process. Um, So, for instance, now this is a little too high, but anyway, here's okay. So, greenhouse gas emission, CO2 per unit electrical energy generated from for some of the fossil for some of the sources. Okay, so this gives you CO2 in kilograms per megawatt hour of energy electricity produced. So you see, coal has the largest carbon footprint, 1,000 kg, 1 ton per megawatt hour. Natural gas has half of that. Solar cell, this is all mostly during the manufacturing process, and this number is based on assumed lifetime and all that. Now there are several different technologies. This number should be a lot lower, but anyway, and this number is one can argue is a lot lower. But anyway, operationally, solar cells, wind and geothermal have zero carbon footprint, and so does hydroelectricity. Okay, so this is all during the manufacturing process. So essentially, so that's why we want to move toward renewable sources because of the zero carbon footprint. This is the culprit. This is the villain we are trying to eliminate. We don't want to increase any more CO2 in the atmosphere. So some of the political factors, if a political party is inclined towards it, the specification of what you want is you want subsidies. The fossil fuel industry has been subsidized for a long time, so you want to give subsidies, incentive, tax exemption, so people will adopt renewable sources faster. Um, by the nature of it, any new technology is initially going to be expensive, and as more and more people adopt it, it'll prices are going to naturally come down. So, and government can also fund programs for energy-related research. And some of the factors that, of course, influence energy policy is you're not going to adopt solar technology if it's too expensive. Uh, if you live in Iceland, you can't do solar cells and so on. So climate and geography play into that. So your energy population policy will depend on various factors. And also, well, so you can't, well, I mean, if you have a disruptive technology, if you have something that's cheap, disruption is bound to happen. Um, Old investment is going to fight the arrival of new technology. But anyway, so there are various things you need to consider. So for instance, you have to solve the problem of with solar and wind, the problem of intermittency of the source. You have to solve. Okay, and here's with new technologies, you have to think of new infrastructure. So if everybody were to drive electric cars, so for instance, in most parts of the world, by 2030, they're going to stop. Most people are going to stop manufacturing gas cars. So if you're going to, most of the cars are going to be electric cars in 15-20 years, we'd better have these recharging stations all over. Some people are betting on hydrogen vehicles. Okay, so you'll have to have hydrogen fueling stations. Hydrogen is a great way to store energy, and the idea is you use solar cells to produce electricity, and then you and the electrolysis of water will give you hydrogen. So essentially, that's one way of storing the sun's energy into hydrogen, and then you can use it in cars, in transportation. Okay. All right. So that chapter gives you the past, present, and future of our energy that the world gets from, and hopefully where we'll get our energy from.